To understand more clearly what energy conservation is, we can make an experiment to support this statement. Our experiment is related to potential energy and elastic energy. Our questions before the experiment are: what is work? What is energy transformation? How is energy conserved? Our task is using the equations of energy formulas that determine the elastic potential energy of helical spring as a function of its extension. After the experiment, we are going to conclude the energy conservation according to demonstrated experiment. The needed equipment for this experiment is a support base, a support rod, 2 bus heads, a weight holder for slotted weights, 3 slotted weights, a helical spring, a spring balance, a holding pin, a plate bed scale, measuring tape, a glass tube holder with tape measure clamp. For the setup, screw the split support rod together. Set up a stand with the support base. Put the support rod into the support base and lock it with the screw. Clamp the extended measuring tape in the glass tube holder and clamp both on the bottom of the support rod. Fix the bus head on the support rod and then fix the holding pin in the bus head. Hang the helical spring in the hole of the holding pin. Adjust the length of the measuring tape so that its zero mark is exactly at the same level as the lower end of the helical spring. Now we can do our experiment. First, we need to do our preliminary experiment 1. Lift a 40 grams mass with a spring balance and observe the balance indicator. Attach the helical spring as close to the top of the support rod as possible. Pull down on the helical spring with the spring balance and observe the indicator at different extensions. Now, preliminary experiment 2. Hang a 40 gram mass on the helical spring and let it fall. Observe the process. Lower the suspension point far enough that the mass just touches the tabletop at the lower reversal point of its oscillation. Hold the mass against the tabletop so that it touches the table, then release it again and observe the continued course of this movement. Now, we are going to do our main experiment that proves the conservation of energy. Hang the weight holder on the helical spring and determine the spring's extension. Increase the mass in increments of 10 grams to max 40 grams and determine for each mass the extension, and record this value in Table 1-2. Calculate the height and record this value in Table 1. Attach the plate on the lower bus head at height which you determined. Lift the mass with the spring balance onto the plate and read the weight force while you're lifting. Record its value in Table 1 in the report. Shift the suspension point of the spring so that its bottom hook is just at the height of the weight holder's hook. Now, hang the weight holder on the spring and let it fall. Observe the process. Repeat the experiment the same way 3 times for the masses 20, 30, and 40 grams. In order to disassemble the support base, you should press the yellow buttons. Now, you're done with your experiment. After completing the evaluation questions, we should deduce that the lifting work is not lost. It is transformed into elastic and kinetic energy. And after the mass falls on the spring, there is still energy in the system. After the main experiment, we should understand that the lifted work is equal to elastic energy and recognize that the elastic energy of a helical spring is proportional to the square of its extension. For our questions, we can say that work is measure of energy transfer that occurs when an object is moved over a distance by an external force. In this experiment, the mass piece had a distance of h or height. And energy transformation is the change of energy from one form into another. In this experiment, at the beginning, the mass piece had gravitational potential energy. After it is released, it had elastic and kinetic energy. The mass piece can get back to the releasing point as it gained elastic energy, so we can also understand that the energy is conserved. It was never lost. In the end, we can conclude that there are tons of ways to prove the conservation of energy.